Hey guys, and welcome back to another video on the channel. In today's video, we're going to be taking a look at 2020's Math Methods External Exam Paper 1, short response question 17. Now, you would have noticed on the channel, I've started splitting up all the exam questions into individual videos. That way, if you only struggle with a certain type of question, you can go watch it on the playlist, and I can go into a bit more depth on each question, and it's not like a 2-hour video on the channel. The full exam video is still up on YouTube. The link is in the description below. If you need a Math Methods External Exam bundle pack, in the description there is a discount code that takes 50% off of it, though it's only from this video. So if you're one of the first people watching this video, go use that code because it will only work for 10 people. Okay, but let's get straight into this guy here. If you have any questions at all during the video, leave something in the comments and I'll try my best to answer it. Okay, question 17, worth 6 marks. The volume of water in a tank is represented by the function of the form, and we're given V of t equals A e to the kt, where V is in liters and t is in minutes. Initially, the volume is 100 liters and it's decreasing by 50 liters per minute. Determine the time at which the volume is decreasing at a rate of 50 over 7 liters per minute. Express your answer in the log form. So what we've got to understand here is what we've been given, okay? So we're given a function where we have the volume is a function of time and we can see it's an exponential curve. Now, they just said there's 100 liters in it and it's decreasing at 50 liters per minute. So in 2 minutes, it's going to be empty, okay? So we can assume this is a negative exponential function that's going to do probably something like this. It's going to decrease very fast and approach 0. Now, the key information we've been given here is this bit here. Initially, volume is 100, and we're also given this bit here, okay? We're given a rate of change, okay? Because they said liters per minute. So this bit here is a derivative. They also said determine the time at which the volume is decreasing, aka at this rate here, which is another derivative, okay? So here, you're told at the start, the word initially means t equals 0. So 0 seconds, the volume is 100. So we can use the information straight away here to work out some things. So if I chuck in t equals 0, I can replace the volume with 100. And let's see if that solves anything, okay? So here, v of 0, and wherever the t is, you replace it with a 0. So you have a, e, k times by 0. Replace that with 100 now, and we've got something like this. Now, e to the 0 is 1. Therefore, 100 is equal to a. So straight away we know what a is. So here we have v of t equals 100 EKT. Now, we need to work out what k is going to be here in order to answer the rest of this question here. Now, they told us as well, at the start, it's decreasing at 50 liters per minute. So what that means is when t is equal to 0, dv dt or v dash of t is equal to negative 50. And the reason why I put negative is because it's decreasing, okay? So the sign is very important here, okay? So first of all, we need to work out an expression for the derivative of this guy here. So we have to differentiate it. So here, I'm going to put just v dash of t. So v dash of t, 100. Now, when you're differentiating the exponential term, you have to use chain rule. So if you were to differentiate the inside function with respect to t, you're just going to get k. So that k comes down the front. So it's times by k times by e to the power of kt, because the derivative of the exponential term doesn't change, okay? So this is what we're given here. Now we have to chuck in this information. So we know when v dash of 0 is equal to negative 50. So we substitute t for 0 straight away. So v dash of 0 equals 100 times by k e, and let's just go k times by 0. And here now we replace that with negative 50. So negative 50 equals 100 k. E to the 0 is just 1, so we can just replace that for that. So we have negative 50 equals 100k. So therefore, k is going to be negative 50 divided by 100. So k is equal to negative a half. Okay. So now we know everything about this equation here. We know exactly when to predict what volume at what moment in time. So we can replace that with a half now. Okay. So now we can actually answer the question roughly, because we've worked out everything about our equation here roughly. Okay. If you have any questions about how we've worked it out or why we've worked it out, leave something in the comments below and I'll try my best to answer it. And I've kind of botched this guy here. I'm just going to rewrite it again. Okay, so this is our equation, and that makes sense because that curve would roughly look like that, which is described definitely here as well. Now, determine the time at which the volume decreasing is at this rate here. So here, we are given v dash of t is equal to negative 50 over 7. So it's our job to work out the time in which that happens pretty much here, okay? And we have to express it in this format here. So first of all, we have to differentiate this again. So v dash of t, bring the negative a half down the front, so you have 100 times by negative a half, e negative a half t. Negative a half times 100 is negative 50, so negative 50 e negative a half t v dash of t. Now, once we've gotten that expression, we can now substitute this information in so far. So we have to replace this guy right there. So we get negative 50 over 7 equals negative 50 e negative a half t. We're going to divide both sides by negative 50. So that's going to give you 1 over 7 equals e negative a half t. Now, the next job here is to log both sides here, because we're going to convert it from a format that looks like this to a format that looks now like this, because we need to get the unknown by itself, and the unknown is the t in this case here, which is in that power. So rewriting this as a log form, it's going to be log e 1 over 7 equals negative a half t. Here we can just write that as ln of 7 to the power of negative 1 to make it a bit easier, and we have that. Now what we can do is times both sides by negative 2 to cancel out the negative half there. So you have negative 2 ln 7 negative 1 equals t. We can then move that negative 2 up in there. So we get ln of 7 negative 1, the power of negative 2, equals t. 7 negative 1 to the negative 2 is the same as 7 negative 1 times by negative 2, which just gives you 7 to the power of 2, which is 49. Therefore, t is equal to log 49, and that is your final correct answer. Okay. Is this a hard question? Yes and no. It's a hard question because it doesn't have dy dx and stuff, and they've used the word increasing or decreasing. The words you've got to look out for here are initially, rate, decreasing, increasing, and the units. Notice here it's liters per minute, and they said liters in minutes. So if it's saying liters changing with minutes, that has to be a derivative. Overall, pretty good question. Will this appear on this year's external exam? Who knows, maybe. This is from 2020. But if you have any questions about this one here, leave something in the comments. If you want the external exam bundle pack, use the discount code in the description, get 50% off. But otherwise, I'll see you in the next video.